Jeversen, and also for the people home. I really hope you have an enjoyable day, and let's start. Okay, good morning. The program is very tight, as I said. We will start with a keynote, followed by the project overview and the main results. You have all a brochure received this morning in which you can see some more details. And after we have done the project overview and the main results, we go to the test track. Coaches will bring us to the turning circle number 1, where we will have a live demonstration of our vehicles. After that, the coaches will bring us to the loading dock number 2, where we get some interesting demonstrations about loading of trailers. And after that, we come back in this hall. We will be transported by coaches, so don't start walking on your own here, because as I said, we are on a test track. After that, we have lunch, and during lunch, the ride and drive. And then in the afternoon, we will have a continuation of the demonstration of innovations. We do that in this hall. And we will talk about the benefits for industry and society. And to close this session, we will have a panel discussion where we have invited some people to join us on stage and to elaborate on the day, what have we seen, what can be done in the future, and how can we implement all the innovations we have developed within our project. And then to close, we have again the opportunity to have a nice getting together, have some drinks and have some food. A warm welcome to Dr. Christian Brenneke from the ZF. He is our host today. I'm very happy that we could join here at ZF Test Track, Christian. It's really a nice opportunity to have a very nice test track, and yeah, you being our host, I think we are in good hands. And yeah, I would like to welcome you, and yeah, the floor is yours. Thank you very much.
Yeah, thanks a lot, Ben, for the introduction, and also from my side, a very, very warm welcome to the test track here in Jeversen. And I'm really happy on behalf of ZF to welcome here all, and especially to see such a broad audience coming from research, from industry, but also from the European Commission. And it's really happy to have all of you here. And especially to have you here on this early morning that are traveling you, but this gives us a chance that all of you can enjoy a live demonstrations and getting a lot of excitement and demonstrations in the AEROFLEX program. ZF, of course, is very proud to be chosen that we can host this grand final of the AEROFLEX program here on this state-of-the-art test track in Jeversen, which is the core of the development for us in developing our safety relevant and efficient programs. And it's a core in the development programs for all of our products. That's why we're focusing a lot of safety, and we recently have extended this test track also to be prepared for all the future technologies towards autonomous driving, connected vehicles, and electrification. And of course, it's really a pleasure and an honor for me to open this event as a keynote speaker. Ben introduced me. My name is Brenneke. I'm since 2008 with WAPCO, going through several roles, and now since 1 year with ZF. We are happy to be acquired by ZF and be now in the process to integrating the two companies, WAPCO and ZF, in the commercial vehicle division. And in this regard, I'm heading the R&D function, the development of all the programs in the commercial vehicle space, and being the Chief Technology Officer for the commercial vehicle part of the division in ZF. Today marks a really important milestone for our industry with the unveiling of many notable achievements in the AEROFLEX program. It follows almost 4 intensive years of collaboration with over 20 leading truck and trailer manufacturers, suppliers, and research institutes across Europe. And by bringing together these diverse capabilities and, more important, the talents to bring this together of these industry leaders, AEROFLEX has enabled us all to play a part in positively shaping the future of transportation. This includes, of course, developing and demonstrating innovative new technologies, concepts, architectures for the complete commercial vehicle and the operation of it. And most crucial, the project has really delivered clear and tangible results. And you will hear a lot of details, impressive facts and figures, so that I just want to keep it simple, that I want to highlight only one that really stands out. AEROFLEX has developed innovations and technologies to improve the fuel efficiency of long-haul transportation by 1/3. I think this is a quite impressive result because 1/3 means 1/3 less fuel, 1/3 less CO2, and of course, a big portion of less cost. The results achieved through AEROFLEX will powerfully raise the bar for the industry on energy efficiency, on safety, and on driver comfort, as well as being flexible and configurable. It also helps us to ensure that the specific needs of individual customers can be satisfied with flexibility and adaptability in their core of operation. This particularly is important in this demanding and over and ever-changing environment we are operating in the commercial vehicle industry. Exactly 4 years ago, this project was launched, and now we can all rightly be proud of what we have been achieved as a team. I will say it one more time so that this message is really clear. We have innovated new technologies and have developed it and demonstrating it, which saves up to 1/3 of fuel and CO2. We as ZF, as a stakeholder in this project, started as WAPCO some time ago, now being in the end closing at ZF, and this at least gives us also the capability to bring even more capable and greater competence into that project. A wider portfolio of products and also solutions what we could contribute to this important projects. ZF's core combined project team brought together experts across engineering, our innovation technology team, aerodynamics, systems, software development, digital systems, and over the course of the project, we have involved more than 50 experts in the execution of that project. Our AEROFLEX participation represents a further significant advance in the ZF's strategy of next generation mobility. Since several years, we're focusing on strongly driving our Vision Zero, means zero accidents and zero emissions, where we're driving and guideline our development of products and portfolio along for truck and trailers, but also for fleet and cargo management solutions. ZF's contribution to this project is including in the key 3 areas of the advanced energy management powertrain, including the smart Dolly, the aerodynamics, and of course, the smart loading. And I'm very pleased to say that a lot of demonstrations can be seen and observed by yourself in the demonstrations and the test ring outside. But not only that, we will see a series of live demonstrations today that will put truck, the dolly, and trailer through their paces. This is a unique opportunity to see the transport of the future begin to take shape. And in this challenging and competitive global environment of technology shifts, there's arguably never been a greater need and time to advance this as today. In these challenging times of technology transformation, we must step back every day and fully consider and rethink the way the transport of the future will look like. And it's important to do this, of course, and consider many factors, including transport as a service, Vision Zero, no emission, electrification, digitalization, automation. However, at the end, what the market wants and our customers want is just to have the right truck at the right time with the right infrastructure. This is required and means a combined transportation, a close collaboration across the industry with logistic partners in the context of this increasing stringent legislation. So what more, all the AEROFLEX participants, including ourselves, has undoubtedly produced tangible new product lines that will have successfully been accelerated through the pre-development. This has brought future transport concept much closer to reality than had we all worked in silos and direct competing with each other. So it now stands, the significant achievement of this project will play a pivotal role in developing the future generations of advanced safety and efficiency systems in a world of increasingly autonomous, connected, and electrified vehicles. So while that future is getting closer and closer each day, a lot of work and a lot of many challenges lay ahead of us and for the industry. Given what we can achieve together, however, I do sincerely hope that we will see a future continuation of the AEROFLEX project. So let's now turn to today's highlights, the live demos, as mentioned before at the test track at Jeversen. We as ZF and this commercial test center really support the development of these advanced technologies to drive the industry vision for a sustainable, autonomous, connected, and electric future for the commercial vehicle industry. And this facility, as we will see today, provides an ideal platform for testing these advanced technologies and an incredibly close to real operation environment. And this, of course, we want to use today to demonstrate the AEROFLEX program. So we are all delighted to showcase some of these key technologies, but now I read a lot, I spoke a lot, so hand over to Ben to bring you to real facts and figures of the day. Thank you.
Thank you very much, Christian. A wonderful speech to have a kickoff of the day. And now we are going to dive into the project. I have to introduce Gert-Jan Coronet from TNO, and you know me already. And with this block, before we go to the test track, we are going to lead you through a very short project overview. Where are we coming from and where are we heading to? Gert-Jan will talk about main results and the impact, and then Julius, Engasser, and Henning Wittig, Julius from MEN Truck and Bus, and Henning from Fraunhofer. They will lead us to the advanced energy management powertrain and the e-Dolly, and then we will go off to the live demonstrations on the test track. As said, Gert-Jan from TNO, myself from Uni Research, and important is, where are we coming from? What are you going to see today? What are we going to talk about today? Today we are going to talk about long-haul transport and high-capacity transport, because we are convinced that one of the first steps we should do in transportation of freight is consolidation of freight, and see how can we use European modular systems. So standard loading units, and build upon these standard loading units all kind of EMS vehicle combinations, so that you can maximize the utilization of the loading units, but also maximize the number of vehicles which can be driven on the road by the minimum of vehicle kilometers. We will see how we are thinking about the optimum between weight and volume in loading units. And we will demonstrate the flexibility in the art of transport. And that means not only road, but also rail, so intermodality or seamless modality. And we want to show you the adaptability of the size of our loading units. This is all transportation of freight and logistics. But we also have developed a lot of innovations within our project, as you will see, vehicle concepts based on standard loading units. We have developed powertrains for the future, even applicable when we will grow into the vehicles with zero-emission powertrains. We will have done extremely lot of work on aerodynamics, and we have looked intensively at the front-end design. And as I said already, all these innovations you will see today, they are able to be incorporated in the future zero-emission vehicles, whether it is a battery-driven vehicle or a fuel cell-driven vehicle. At the beginning of the project, we had defined some goals and objectives. And we started with the boundaries to see what are the constraints and the boundaries in which transportation of freight is taking place. From that, we derived what kind of technology and innovations we need. So you see, we have focused on technologies, but also vehicle concepts, the architecture, and standards, because we found out standards is one of the most important issues when you talk about future technologies, which are all digitalized in their application. So we really should think digital if we talk about new technologies and innovations, and for that you need standards. Standards, how to deal with this kind of intelligent powertrains, intelligent aerodynamics, but also intelligent loading units and access to the infrastructure. So from that, we had set up an extremely fast demonstration program where certainly TNO played an important role, and we looked into what kind of recommendations can we provide for these new standards and how to implement that in the framework. These goals and objectives were also split in concrete targets. Targets when we talk about separate platforms and the efficient load of loading units, as the example shows in bringing a trailer to the train. We talked about energy efficiency and energy savings when we talk about our vehicles concept, the powertrain and the aerodynamic. And we have looked in detail to the front-end design in combination with the aerodynamics and to see how can we improve the survivability in crashes. What was the end result? Today you will see our demonstrators and you will see our innovations. You will see them live, and you will see how we are going to build from one vehicle another vehicle and build all kinds of vehicle configurations just to show how it is possible with the use of standard loading units, which are intermodal, that we can build different vehicle configurations to suit the circumstances the infrastructure allow us to drive this kind of vehicles and to minimize vehicle kilometers and to maximize the freight transport on road, but also on multi-mode applications like railroad. We have designed a roadmap, and we were very happy in the first week of September, where we have published through our website, our news bulletin, the intelligent access policies. And we described we are in the year 2030, and we did that deliberately. Well, we wanted to show what should have been done if we are in 2030 and we have managed to implement access policies where you can use all these innovations and technologies we are going to present today. A very interesting news bulletin, and it will be also one of our last presentations today. And I'm happy that also Steve Phillips is here from Sailor, because he certainly will add something to this. all deliverables are available on our website. So even after the day, click on our website and you will see all the deliverables. You will see also the whole program of today, also the live demonstrations of the day. So no information get lost. And we have also a very close collaboration with the ALICE platform, the Alliance for Logistics Innovation through Collaboration. And they are also going to support our website so that in the future, this website will be continue to stay alive so that all the knowledge is available for anyone who wants to hear it. I want to thank our stakeholders. I want to thank you, because without our sounding board, we didn't achieve the results as we have achieved. And we started with a sounding board of only 36 people. In the meantime, we have a sounding board over 70 people, and most of you are here, are our sounding board, and we had always intense conversations with our sounding board members that we got feedback from you, critical feedback. I can remember some very emotional discussions we even had, but this is necessary. If you look in the future and you want to be innovative and you want to digitalize technologies, you should listen to each other. And for that, I think you as stakeholders, you deserve a big applause for yourself. So, what happened in the past years? When we started with our project, we were all thinking about the physical internet. And yes, we were talking about CO2 emissions, but that was not really the key. The key was at that moment the physical internet. But very soon we were confronted with the Green Deal, the roadmap to zero, and COVID showed us how digitalization is a game changer, because really we were suddenly confronted with huge problems and challenges, how to get on with the situation we were. So in the middle of our project, we also had to slightly change our way forward, and we spent a lot of time can we contribute to this new focus on zero-emission logistics, powered by the physical internet still, because that is the logistics behind, and how can we contribute to the development of zero-emission vehicles and the automation and the digitalization. So by that, we had a deep look in where are the levers to gain, to make it better. So we looked at the transport of cost, not only the vehicle, but also the impact of the transport, as you can see in the picture on the top right. Of course, we showed also to the cost of the vehicles, but I think it is much more important to look at the cost of the impact. And by that, it was logic that we changed on the focus heavily on impact of climate, road accidents, and TCO and pre- and post-haulage processes. We start to look intensively at the multimodality. So how can we make the best use of all the modes we have available? And we saw that there are always a few criteria immense important. The time, the duration from A to B, but also the probability. How sure am I that I arrive on time? Because if a logistics operator doesn't arrive on time, probably the goods are too late, and if it is fresh food, you can throw them away. So we have seen that all these levers are very important to take with us in our project. So today we are going to show you what is our contribution within AEROFLEX project to this new stream that we want to contribute to the roadmap to zero-emission vehicles and zero-emission logistics. And Gert-Jan will take over for me, and he will dive in the main results of our project. And yeah, thank you. And Gert-Jan, stage is yours.
Thank you, Ben. Good morning, everybody. I have the pleasure to take you with me with the main results of the project. And I immediately would like to say lots of results in the afternoon sessions as well. I can only give you an overview. but we have the opportunity to take a deep dive in the afternoon of all the great things we did. So the impact of AEROFLEX. We focus a lot on transport efficiency, but certainly not alone. So we will also discuss the impact on the 2.0 ambition, and of course on the societal impact. First, did we meet the goals of the project? Yes, we did. I'm not going into details about all the numbers and the how and the ifs. You will see that along the day. Yes, we meet the goals of the project, or we came really close. Two important remarks. So if you look at the overall efficiency gains, we noticed, of course, that this is very dependent on the use case. And for that reason, we did over 50 interviews with logistic operators to construct use cases, and 8 of those use cases were selected to do the full analysis of the impact on the efficiency. And there we clearly see that there are lots of influential factors which in the end determine the efficiency gain. Then the energy efficiency improvement by the advanced powertrain. We came far with reaching the goals, but we also learned that we need plug-in functionality, or for instance the Dolly, to really reach the goals we have set. So that's an important remark for the future work. So I will give you an overview of the impact on the transport efficiency. But first, looking at how to look at efficiency in transport. And you can look at that in a very simple way, I think. First, of course, we have to consider if we really have to move the goods we want to move. If we want to move goods, then we select the mode to do that as efficient as possible. And that's the scope of AEROFLEX. That's the area we work, the mode choice, the reduction of energy, the aerodynamics, everything is related to efficiency. And then you select the most effective way to decarbonize. In that order, you don't start with decarbonization, you first start with, do I really need to move goods? And then you do it as efficient as possible. And this is another way of looking at it. So don't worry, it's hopefully the only formula of today, but this is the message of the formula, is that you have to look at different system levels of transport. And in that system levels, you can optimize the efficiency and in the end, the carbon intensity. And that's the way we looked at it in the project. And that's why we did the innovations which hook on to different system levels in the transport chain. So that was the only formula, but just a little bit of technical stuff to make you understand, if you do not already, how to look at efficiency. Because we have to compare apples to apples, and then we cannot only look at the liters of fuel used per kilometer, but then we have to introduce the ton kilometer. And a ton kilometer is transporting 1 ton over a distance of 1 kilometer. It's as simple as that. That means that if you are able to transport 2 tons, that you reduce your efficiency by 50%. But you have to, of course, look at how much more fuel you use because the vehicle is heavier. In the end, then you get the liters per ton kilometer. That's the way we have to look at this to really compare modes, to compare vehicle configurations, and to introduce also the effect of the innovations. So these are 2 examples of the results of our project. These are 2 of the use cases, the customer use cases we selected. 2 very, very different ones. I will go into a little bit of more detail later. And here you see that when we compare the fuel efficiency with a tractor-trailer, and we look at different vehicle configurations which are possible for these specific use cases, and we then add the innovations, which are called AERO and AEMPT. I won't bore you with more of those abbreviations, the hybridization and the aerodynamics. If possible, smart loading, and then you see that we can go up to 50% reduction in the energy use per ton kilometer. In the second one, you see that we come to 30% of switching to different vehicle configurations and adding the innovations, which might make the total vehicle more efficient. So if you look at transport efficiency, I think we should not start at the vehicle technology. You first look at the cargo. And then you see that in a very simple way, if we looked at the customer use cases, we can kind of divide that into mass-limited transport, volume-limited transport, and a situation where the floor space is limited, where you cannot stack pallets on each other, for instance. And that the potential of the reduction in energy efficiency, or the increase in energy efficiency, I have to say, is totally depending on, of course, the cargo transported and the innovations you can apply. So, for instance, for mass limited, you can increase the vehicle length, but with a limit, of course, with the total gross combination weight, which is allowed. But looking at volume limited, it makes perfect sense to add, for instance, 2 trailers. With floor space limited, there's another possibility by looking at the double floor, which you will see later today. So that's a way we then select the vehicles which are most applicable, and also given, of course, by the customers, the end customers we interviewed. They selected the vehicles they wanted ideally. And then we add the innovations in that order. So, an example. This is a use case transporting automotive parts from Germany to Spain, which are packed in so-called gitter boxes to fill the trailers optimal, often by train, partly by train, so that also has to be possible. And this customer selected both an EMS1 vehicle, so a 25-meter combination, and an EMS2 vehicle, double trailer, 32 meters, as potential future candidates for this transport. So what we then do is look at elevation, the terrain and the geo. We look at the payload, of course. We look at speed profiles, which are a result. And here you see that we have in this transport back and forward a mass limited and a volume limited one. So this is a complicated graph, and that's why I hide a lot, because more details in the afternoon. But you see here in the orange bars the increase of the fuel in liter per kilometer, but the decrease in fuel in liter per ton kilometer. And then this is the volume limited use case where you can go up to 36% on a ton kilometer basis. The mass limited, of course, has less potential because you quicker reach the limit and you can transport less cargo. Another example, quick one. This is lightweight products on pallets which are not stackable. So you can only use the floor space there is, and that's it. So in this case, it makes perfect sense to introduce the double load floor and the other innovations we use, and of course use the longest vehicle which we can find. So same procedure, and here you can see the example of going up to 50% of fuel reduction in liter per ton kilometer. So again, more information in the afternoon sessions about all the use cases we calculated. This is just a quick overview of the potential of gathering the innovations. So, and again, I want to emphasize how important it is that that we look at this realistic customer use case. That's also what I really liked about the project, that we had direct contact with lots of sounding board members who are in the daily operation, who teach us how daily practice really works. And in the project, we developed an assessment framework which is capable of calculating all routes in Europe. Even the 10T routes are calculated to assess the impact of potential innovations and vehicle configurations. The impact on zero-emission logistics, which was, of course, not a clear goal in the beginning of the project, but later it became more relevant by the minute, as Ben already indicated. And of course, we have the e-Dolly. The e-Dolly is an electrification by itself, and you will see today the impact, the direct impact of the e-Dolly in maneuvering in energy efficiency. But you also need to look at it in a bit different way. All the energy savings you can achieve have a direct positive impact on the electrification of the vehicle. Whether it's battery electric, whether it's hydrogen electric, that doesn't matter, because the less energy you have to use, the easier it is to come up with a viable vehicle for long-distance transport. So in this case, by adding the aerodynamic and the hybridization innovations, we can save up to 5 to 15% per ton kilometer again, which is already a step in the right direction. The impact on society. Here we have to mention the role of the truck driver. Easily forgotten, but very important. We have a huge shortage on truck drivers. And the easy message, of course, is if we make vehicles more efficient and longer, we need less truck drivers, and we can help the shortage on professional drivers. But also, which is maybe even more important, a truck driver wants to drive. And our innovations help time savings around the distribution center, and that the driver can really do what he wants to do best, and that's driving. Now we need to click forward. So I can stay, of course, with the truck driver and talk long about that, but that was not the idea. Right, safety. I talked a lot about transport efficiency, but we really need to emphasize the new front-end design, which was developed within the project, not only for aerodynamics, but especially to integrate active and passive safety measures. And one of the you will see lots of information and details this afternoon, but one of the key messages is that we really, from this project, want to contribute to the Vision Zero ambition, but also to support the creation of consumer programs such as Euro NCAP for passenger cars. So you will learn more this afternoon on the safety aspects. Then finally, like Ben said, the mega trends of digitalization and intelligent access in logistics. Intelligent access, we know now with how that works in cities with zero-emission vehicles allowance in cities, but it is also very important for the longer and heavier vehicles and the allowance on the roads. And this digitalization, data sharing, and intelligent access go hand in hand with the 2.0 ambition and our innovations. So we will talk a lot about intelligent access this afternoon and make sure that it's being handed over to the future. So we are convinced that the AEROFLEX innovations can really significantly reduce the vehicle kilometers, which is also need to be not forgotten, reducing vehicle kilometers and increase transport efficiency and being a building block for zero-emission logistics. Thank you for your attention.
Thank you very much, Gert-Jan. Julius and Henning are getting lined up. So I have a question for you. We see a lot of vehicle concepts. I see a lot of EMS vehicles. Not to give the wrong impression, but are these innovations we have developed and these new technologies, are are these also applicable for standard vehicles as we have them today on the road?
Oh, that's absolutely. That's a very nice question, because in the customer use cases, it was not only about these EMS vehicles, it was also about customers who simply want to increase their transport efficiency with their existing tractor trailer or existing truck semi-trailer. So yes, what we did is to match the characteristics of the innovations with the intended vehicle configuration, long, short, whatever the customer wanted, to really make it dedicated. So both aerodynamics as hybridization are fit for purpose.
Okay, thank you very much. I allow one question out of the room. Does somebody has an urgent question? It seems to be crystal clear what we have told till now. Then I would like to thank you, Gert-Jan. Thank you very much for this overview. And I would like to welcome Julius Engasser from MEN Truck and Bus. He has led the topic of advanced energy management powertrain, and Henning Wittig, who has also led the development of the smart power Dolly. You see also there were some other partners involved in this part of our project. And yeah, Julius and Henning will guide us through the technology of new powertrains and the smart Dolly. Please.
Thank you, Ben. Yeah. Can you hear me? Is that working already? Yeah. Yeah, good morning from my side. Julius Engasser from MEN Truck and Bus. As Ben said, I had the pleasure to lead work package 2, which is about the distributed powertrain. We had a few other partners which really worked hard to make that happen, and now I'm really happy to present the results to you. Our task was to develop a distributed powertrain system for EMS vehicles. Therefore, of course, we had to implement a control system to control such a powertrain, find a suitable energy management strategy, develop a new communication protocol for the vehicle units to talk properly to each other, and finally build a demonstrator to prove that this concept can work. The basic ideas are pretty simple, and I think also easy to understand for non-technicals. The important idea is to save fuel. So we have a combustion engine in front. Normally brake energy is lost. We want to use that, recuperate the energy, and thereby use fuel. The second idea is increase of traction and performance. In long and heavy vehicle, we have a lot of axles. If we only have one driven axles, we have a traction problem. We solve that by adding additional electric axles to the system. And last but not least, we allow trailer maneuvering with its own or driven axles from a Dolly, which, for example, in the future can be used for autonomous yard operation and so on. So that's the technical concept we came up with. We basically have a global energy and torque management system in the truck, which comes up with an optimal operating strategy to make these different drives to make up a suitable and consistent system out of them. The several units, they are connected via our new AEROFLEX protocol, which is based on automotive Ethernet communication. We have way more bandwidth and data rate than in CAN communication. But do not have to make compromises in safety as it would be with an additional Wi-Fi connection. In each trailer system, we have sub-control units, which then implement the instructions coming from the truck and in turn communicating what's the status of the system. We do not have a high voltage line between the systems because that's a lot of people ask the question, but that doesn't make the system more efficient or bring any other big advantage. That's our core function. We implemented in the system. In state-of-the-art trucks, or in all trucks, we have 2 different brake systems. We have an endurance brake and we have a service brake. And we are able to recuperate energy for both systems. So for this endurance brake, that's activated by, for example, the driver or a assistant function. So these brake requests, which normally go to the endurance brake systems of the truck, are now directed to the electric drive with a high priority to the electric drives in the back, and thereby we can recuperate and use that energy. Also for service brake blending, where basically each axle is, or each unit is acting independently. Also there we have local functions which are able to also use that energy. And finally we can use that electric drives to put our combustion engine in a more efficient operating point by, for example, assisting if there is a very high torque request. A few words about torque management, because that's also an issue we really look deeply at. What do these additional drives do with the system stability? Finally, we want to have a safe and stable truck. And the basic principles are very easy to understand, I think. First principle is we don't push the truck. We always have we restrict the torque in a way that we always have a pulled system. The second principle is we try to distribute torque between the electric drive as even as possible. And the third principle is we reduce torque if we have a more dynamic or we have a higher lateral acceleration. So as more if we run through a curve, we reduce the maximum torque, and we are on the straight, we allow the system to work on full potential. And that's how the demonstrator looked like, which we built according to these principles. We have a conventional truck in front with the global energy and torque management system, a new communication line in the middle. We have the Dolly, which Henning is going to talk about more in detail in a few minutes. And we have the trailer, which we took over from a past project Transformers, within also an electric drive on the last axle. After building the demonstrator, the vehicle went to Spain, to IDIADA, who performed an extensive test program. The demonstrator was run over 5,000 kilometers on Spanish highways to measure, okay, first, does the concept work, and secondly, how much fuel saving can be realized. We could measure a fuel saving of 3.5%, where it has to be said that in this system, of course, a lot of prototype restrictions are still in. So if we would take away these prototype restrictions, we could raise the savings to 10.1%. It has to be said on that specific route, which is rather hilly and therefore a good route to operate such a hybrid system. We had one test where we indeed measured a saving of more than 13%, where we started with very full batteries and ended with rather low batteries. So this is a kind of plug-in drive. So that's according to what Ben also mentioned before. basically, if you want to operate such a system with really high saving rates, you have to operate that as a plug-in system. And I want to close with a small outlook. What did we learn, and what results can we derive for the future? First of all, when we started the project in about 4 years ago, hybrid system indeed were an interesting option to look at. Now in 2021, we are on a very clear path to zero emissions. So actually, we are really, I think all our industry is going straight to battery electric vehicles or fuel cell vehicles. So the hybrid technology we see in that project is not taking us to that goal. But it is important to note that the technology we developed is one-to-one usable also in a zero-emission vehicle. So the distributed powertrain, as an idea in itself, is useful in all drivetrain concepts. There are obstacles if we look at this at the future of the technology. First of all, and I think we're going to talk about that a lot more today, is we have still a low market penetration of EMS vehicle, which did not change that much in the last years. We still have the same regulative obstacles like cross-border traffic, etc. And I mean, we had two main motivations for that system. First is reducing CO2, and second is what can we do about driver shortage? And for both big problems, there are also alternative paths. So reducing CO2, there is also a path via BEV and hydrogen, and automation, which is also taking up speed, is certainly also a path to overcome driver shortage. So these 2 points as kind of starting point for the discussion we hopefully have later. And now I would like to give over to Henning, who's going to explain you in detail how the really great Dolly system is working. Henning.
Thank you. Good morning. Also from my side, my name is Henning Wittig from Fraunhofer-Institut for Transportation and Infrastructure Systems, and I will present you the Smart Power Dolly, an electrically driven dolly that was developed according to the concept of the distributed powertrain Julius just presented. So on the one hand, the electrically driven dolly aims to save fuel and increase traction and performance of EMS vehicles by introducing an additional electric powertrain. And on the other hand, it enables automated operation of the dolly without a towing truck for shunting of semi-trailers, for example, on terminals or hubs. So on this slide, you can see some of the technical details. The base vehicle developed by Brenneke trailers follows the concept of a 2-axle converter dolly with a drawbar and a fifth wheel coupling. And shown here clockwise from the top right, the drivetrain is powered by a high voltage battery from Engasser with 73.5 kilowatt hours. It is driven by the ZF AVE 130 portal electric axle with a peak power of 250 kilowatt, and it's equipped with a hydraulically steered axle. All the components are controlled by a local system management that is also responsible for communication with the global energy management located in the truck. We have 2 cooling circuits because of the different temperature levels of the components. So we have one cooling circuit for the electric motors and the inverters, and we have a second cooling circuit for the high voltage battery. Also installed is a data logger to monitor all relevant information of the entire system. This data logger is connected to a server and a web interface, so it enables almost real-time monitoring of the system from wherever you have internet connection. And last but not least, the steering is realized by a hydraulic steering system by VSE. So, given this equipment, the Dolly supports three main core functions. It can support the truck while driving. Propulsion requests are sent by the global energy management in the truck, independence of the propulsion support, propulsion request sent by the either by the acceleration pedal or by the cruise control. Second, it supports brake requests and thus can recuperate brake energy. This is triggered either by an endurance brake request or by a service brake request. While the endurance brake request is forwarded by the global energy management, the service brake request is forwarded by the local EBS of the Dolly, where a dedicated brake blending function is implemented. And third, the Dolly can be driven separately, while then the drivetrain and the braking system is controlled by a remote control. What are the advantages and opportunities? Besides the advantage of using a converter Dolly to build up EMS vehicles, the electric drivetrain in this Dolly enables much more flexibility and adaptability of such vehicle combinations. This drivetrain enables to operate such vehicles with standard trucks or tractors, with conventional or even downsized engines, and in future it might even be possible to operate such vehicle combinations with electric trucks. Furthermore, the electric drivetrain enables to split vehicle combinations, as you can see down here in the video. So it is much more easy and safe to handle long vehicles on terminals or hubs. You don't have to shunt these long vehicle combinations. You don't have to decouple the semi-trailer and couple it to an additional tractor. And thus you can reduce time for coupling, as well as number of trucks and number of drivers needed for shunting. And in future, this manual operation, this manual driving of the Dolly can, of course, be further developed in an autonomous driving. Which means that the Dolly will then be operated by control center software, for example, like HaleyOS. The advantages, I think, are obvious. This control center software knows like the big picture of the yard, so it knows all vehicles, it knows timely constraints of the transports, etc. It improves safety, as it can coordinate the shunting routes of several vehicles, and you even can control and monitor the vehicles from wherever you want. You don't necessarily have to be at the terminal. And to establish autonomous driving on yards also has several advantages compared to public roads. Such yards are a controlled environment, so you know all vehicles, you know the pedestrians, so you can almost eliminate unexpected behavior of road users. You have lower requirements regarding functional safety, and thus there is a quick benefit regarding handling, safety, and planning. And for all those reasons, the Smart Power Dolly was equipped with remote control to pave the way for future projects in this field of development. So, thank you.
Okay, thank you very much, Julius and Henning. I can allow, one or two questions. Steve. Microphone. I have here a microphone. Hang on. Please.
Thanks, can I go like this? Thanks. That was a really brilliant presentation. I really appreciate it. I guess. Well, you can see I've got dozens of questions, but I'll limit it to two, as you said, one for each of you. Julius, you mentioned, you know, when you have a traction problem. Okay, you have a traction problem, we have a pavement damage problem, and I wondered, you know, if you have any comments on the potential reduction in pavement damage that can come from your system. And I guess the corollary to that is also, you know, in many situations we also have a winter traction problem, particularly a winter traction problem. So does it overcome to that? And Henning, again, I have dozens and dozens of questions. I guess my immediate one kind of refers a little bit back to the first presentation when we talked about efficiency. You talk there about yards. I'm thinking about the possibilities of truck parkings. Oh, yeah. Is that something that you could consider in your system?
Maybe, to the traction. I'm not sure whether I understand your question 100%, but if you, I'm not too familiar of how this traction problem is related to these pavement problems. But basically, following this kind of distributed powertrain idea, you're basically free to really distribute the torque in a way that you want. I mean, in any kind you distribute it from one axle to more axles, you always will have an improvement. Yeah. So that's, I think, the simple answer.
Yeah, so this is, of course, one other big advantage of splitting those vehicles, because, it is a problem to maneuver such long vehicles in parking areas. And so by splitting these vehicles, you can still use the existing parking lots to, park these vehicles side by side. Mm-hmm.
So even there are already available on the market automatic coupling systems. So we didn't do that on our vehicle because this is an early prototype. But if you would equip this with an automatic coupling system, which is also coupling air and electricity, then when this kind of vehicle enters a parking bay or a fuel station, you can disconnect the dolly from the vehicle, and the dolly can look for its own parking place, and the truck can take fuel, or in the future charge the battery and look for its own parking. So we see this splitting as one of the biggest advantages, independent from, yes, you can save energy. I think the idea behind it contributes to energy saving and energy efficiency, but it much more contributes to automation of handling in an existing infrastructure, because that's what we want to look at. Are we able to use our innovation in an existing infrastructure without building new infrastructure? Because there is already a lot of square kilometers used as infrastructure. So that was one of the ideas behind. Other question? Yeah, hang on, Thomas, I will come to you. Good morning, by the way. You are too late, but...
It's a bit late. It was a question about driver shortage, because you said it can be solved by automated vehicles. But when do you think you will have that on public roads in a full scale? because I think it will take plenty of years before you are there, so you need to solve it before that. Yeah. But a guess from you would be nice.
I think this question is a bit out of scope of this this talk here. So I don't want to make a guess there, but I think your suggestion is absolutely right. That does not happen tomorrow. This automation technology is not solving our driving problems today, and of course, like these kind of vehicles are able to solve it basically today. Yeah. So that's right. If you look at this question on a timeline, then this is the fastest solution. Yeah, that's right.
That was the reason I wanted to say.
Yeah.
Your idea is very good.
Yeah. Yeah.
So we should see this really as a bridge into the future. So let's use EMS vehicles to reduce the number of drivers, but also to reduce the number of vehicle kilometers. I think this is something which is underestimated, the impact of for vehicle kilometers. And then later, if we really have automation level up to 5, then you can also talk about, okay, now we are contributing to solving a driver's shortage, but this is already a first step you can do tomorrow. We don't have to wait. And this is one of the big advantages. But this is a question of, do we want this? So I may allow one question more, looking at people in the back who have to tell me when it's time to leave here. I think yes. Yeah, one question more. Well, okay. Yeah, okay. Hang on. Banked, I believe. Yep. Banked, please.
Yes, I was thinking about when you said that you could combine electric truck with the electric Dolly. And of course, there is a signal interface between these units, which has to be standardized. I was thinking, do we also need an energy interface? Because I think maybe they need to kind of equalize the battery levels. It needs to act as one battery.
Yeah. So indeed, if we have an electric drive in the front, the issue having a high voltage link is a bit different than in our system now. I think for most use cases, the answer is still the same. That it's technically it's not possible to simply connect energy storages because you have different voltage levels. You will have a short circuit and destroy your system. So you will need power electronics in between. So every link you make is expensive and technically not so easy. And on the other hand, you don't really get a big advantage because energy balancing you can also do via simply distributing the torque requests differently in your system. You don't need to really exchange energy via a high voltage connection. So there are use cases like, for example, you only would need one plug for charging the system if you have a connection or something. There are advantages, but they are not very big in terms of efficiency of the system.
Okay, thank you. Well, that was an interesting story from you both. Thank you very much. And yeah, we will see you then outside. And during lunch, we can still answer questions which people might have. Right, so that was the kickoff of our final event. That's always exciting when you have a kickoff. You never know how it works, but all works fine. And I also understood that the people at home can really follow the live stream very well. And that's one of the worrying thing we had at the beginning, but I understood people at home can follow the live stream very well. We are now leaving this room. If we look at my side, then we see the tractor unit with semi-trailer, which is a standard vehicle you see on the motorways today. So a standard tractor unit 4x2 and a 3-axle semi-trailer, but it has already one innovation which is also developed within the AEROFLEX project, and ZF has developed in parallel here this innovation. This is the so-called e-trailer. So you have seen this morning that the hybrid distributed powertrain makes use of E-axles in vehicle units. So this trailer is already equipped with a E-axle, and this is already the first step in our path of introducing innovations towards zero-emission vehicles. So, starting with the normal standard tractor semi-trailer, you will see at the far end of our test track our two demonstrators. The left vehicle is the advanced energy management powertrain vehicle, and the left vehicle at the end is the AEROLOAD vehicle. So we will now start with the demonstration, and the tractor unit with the ZFE trailer will now leave this area. And we see at the end of the test track that the AEMPT vehicle with the distributed powertrain is already approaching our turning circle. And as Julius and Henning already has explained, this vehicle is equipped with a standard drivetrain. And after the vehicle we see the Dolly. The first axle of the Dolly is hydraulically steered. The second axle has an electric drive, and the transformer trailer has an electric drive on the third axle. Further, this vehicle is equipped with a boat tail. You see the boat tail is out, so if the vehicle is on the motorway, it will reduce the tolerances, the air distribution. There are also side skirts mounted, and you see the side skirts do have extensions to further reduce air turbulences. The AEMPT, so the distributed powertrain, and the aero features on the truck can work together and in a seamless way, so by that you have the maximum savings of energy and optimal air drag under all circumstances. Now the vehicle will come to a standstill, and the standstill is at the left side. This is the moment the truck is arriving at a terminal or fuel station, and the driver will disconnect the dolly from the vehicle so that the vehicle can move to its own destination, and later the dolly will be moved to its own destination. As said already during the presentation in the hall, we still do this manually, but at this moment there are already automatic coupling systems available in the market. So by using automatic coupling systems, you could indeed reduce the time of uncoupling or coupling. But for this test, we have chosen the manual operation simply because at the moment we started this project, these features were not yet available, so we had to choose what is available. So, now the vehicle is decoupled and the pulling truck is leaving the area and it goes to its own destination. Now the vehicle is connected to the remote control and will soon start its way to its own position. And you see at the left-hand side a pylon where I am standing. Here I'm standing. So the trailer will be moved to this area. You see, we have chosen for remote control because in most terminals and yards we have remote controlled operations, because one manager can of course move more than one trailer at one time. So, but in future of course you can easily do this also by autonomous operation. You see that the moving is very easy and it is not a high job to do this. Could be. So the question is there also a follow me feature? Could be possible because there is this Helios program which we talked about in the hall. If you install that, then when the vehicle is arriving at the terminal, then the operator can say, okay, go from A to B, and that's then a follow me positioning. So in the meantime, if we all turn around again, then the AEROLOAD vehicle is approaching. The AEROLOAD vehicle is equipped with 14 features, and in the position we see the vehicle arriving is that the roof of the semi-trailer is in the lowered position at the end to simulate a dolphin position, and also here the flaps are out, which is a normal position when the vehicle is driving on a motorway. Further, this vehicle is equipped with passive elements as the side skirts, the truck chassis covers, the dolly skirts, and we have the activated aerodynamic vehicles, which are controlled by the so-called aerodynamic vehicle control system. How this aerodynamic vehicle control system will work, we will hear straight after the lunch by Andelko Glavinic from ZF, who was responsible for the development of the communication. What is to be highlighted about the vehicle dynamics, the aerodynamics, they can be actively open and closed during driving. The bow tail automatically opens at 75 kilometers an hour, and it's closing at at a speed of 15 kilometers per hour. And by that, if we have to take regional operations, then the bow tail is closing on time. As seen, the ROI is now at the end of the trailer to move the trailer roof in its highest position, and this can be done also automatically, and this depends of course on the load in the trailer. Many trailers are partially empty all the time, so it makes sense that if a trailer is partly empty, that the roof of the trailer will be adapted in the position so that it can further reduce the aerodynamics and by that the fuel consumption. We see between the vehicle, the towing vehicle and the semi-trailer, we see also flaps, the so-called gap reducers. They are, in this test we can show you today, closed, because if we are cornering with this kind of features, the flaps needs to be closed, otherwise they would damage, because the flaps are closing the gap between the towing truck and the trailer. So for the demonstration here we have closed these gap reducers. later in the afternoon when Per, Roy and Jaap are going to demonstrate the features. We will show you a small video that these gap reducers are also operating fully automatically. So the vehicle will now continue and we'll look for the position in front of the second semi-trailer with the E-Dolly, so that we are going to build another vehicle configuration. As said, we are talking about standard loading units, so we are talking about a body length of 7.8 meter on the towing truck. We are talking about a 30.6 meter semi-trailer behind the vehicle, and now it is approaching again the yard, so to say the simulation in our test, and it is going into its position so that the dolly will move towards the trailer to couple in a new vehicle configuration. So the vehicle comes at a standstill and we can now move the dolly towards the semi-trailer and to couple it up to the trailer. The vehicle which we will have then is of course a very long vehicle. It is over 40 meters long, and this vehicle is of course already used in some Scandinavian countries, for example, and is a perfect solution when we have to transport high amount of loads on typical roads where we don't have the possibility to use other modes, for example, but you need to reduce cost of transportation. So this is one solution which can be used for national and regional applications for very specific commodities which we have to transport. You see that the coupling of the trailer to the dolly to the trailer, it's going fairly easy. Yes, it is manual operated, Steve, so you nick your head. But if you further develop these technologies and with some sensoric, then you can do it automatically. But in this case, as said, we will do it manually. You see that the vehicles are all nicely in line, and the middle trailer, the roof is now in its upright position. You see also that the second trailer has also an aerodynamic front end, so that you also can minimize turbulences also in a cornering position. The vehicle is now nearly connected up, so the driver can follow his route to his next destination. So now the vehicle is leaving its destination, and imaginary, it is now going to the next hub to deliver the trailers to another position. As said, we have here now two trailers of 13.6 meters, and the towing vehicle has a body of 7.8 meter. So all in all, we are talking here about a prime candidate which is built up out of standard loading units, as said, for typical national and regional applications, where the infrastructure enables the use of this kind of vehicles, and are other options of transport not possible. The vehicle is now arriving to its destination, and the pulling vehicle will now decouple from the first trailer. In the meantime, a standard tractor unit is again arriving on your right-hand side. And this standard tractor unit is now going to couple the first trailer so that we can have then a standard tractor unit with 2 semi-trailers, with the idea that 2 semi-trailers will be then transported to a rail hub. And we believe that this kind of vehicle combinations can really support the railroad cargo transport, because we are transporting 2 standard semi-trailers. And it is always a good thing if we are able to support multimodal transport of vehicles, so that you can minimize the number of trucks on the road and maximize the number of trailers on a rail system. So the driver is now decoupling the dolly from the first trailer and will then go to its own destination. By the way, this kind of combinations, we have called them EMS2 vehicles. EMS1 vehicle are the so-called vehicles which have a length of 25 meters, 25 centimeters, and EMS2 vehicles are the vehicles which are above this length. So in this case, it is close to 40 meter. And when we are going to put the tractor unit in front of this combination, we will then have a vehicle of about 32 meters length. And this is then a typical practical EMS2 vehicle where you have a standard tractor unit 4x2 with 2 semi-trailers, and then using the hybrid distributed powertrain, so the advanced energy management powertrain, with the electric driven axle on the dolly and the electric driven axle on the semi-trailer. By that I have 3 drive axles, the one on the tractor unit, the one on the dolly, and the one on the semi-trailer. And by that, as Julius explained during his presentation, the traction is ensured of these vehicles under all circumstances, and also vehicle stability is ensured under all circumstances. So all in all, this is a very nice opportunity to use today already standard tractor units, as we have many running around in Europe and will have running around in the coming years in Europe, in combination with electrified vehicle units like the dolly and the semi-trailer. And by that we could move a lot of trailers and cargo with standard vehicle units and then operating in a multimodal concept. Now the vehicle is connected up. The tractor unit is now coupled, and the trailer legs will be inhaled, and then the electricity, etc. And then the vehicle can leave the turning circle. The vehicle will leave the turning circle via an exit at the other end of the turning circle. This is a very narrow cornering, it's a S cornering, and it demonstrates very nicely that this kind of vehicles can operate normally in the existing infrastructure. Because of the drive axle, the steered axles, the vehicle can really follow the routes as we have in most European areas. And once again, this kind of vehicles are vehicles for long-haul operations at regional, national, but also cross-border levels. And they are not entering, of course, urban areas, because there we have the hubs around a urban area, and around and up, normally the cargo is splitted and divided over typical distribution trucks for urban application. So the vehicle is now leaving the test track. As said, the cornering there is a S-corner. It's a pretty tight cornering, but you will see that the vehicle is moving very smoothly to this cornering and exit of the test circuit. Now, the vehicle is leaving the test circuit, and the 3 coaches will now pick us up again, and we will then go to the loading dock. At the loading dock, we are going to demonstrate you the double floor trailer. The trailer you saw with the movable roof, that is the Van Eck trailer, which has a double floor system. And inside this trailer, we have also the new loading units, which are developed in close collaboration with the Clusters 2.0 project. Who has the responsibility to development of the Van Eck trailer, and Gafur from ZF, who has the responsibility for the development of the cargo volume detection. All 3 will do the demonstration, so I will hand over. And Ton, take your time. We have a little bit of time. We don't have time stress. It's good weather, so we don't need to be afraid that we get wet. Ton, please.
Hello, welcome to the loading dock here in the ZF testing center. After the show of the vehicles in the oval, we now want to show you the Van Eck adaptable trailer here on the loading dock. This is what I call the AEROFLEXible trailer. The trailer can be adapted to its mission. And as you saw in the oval, it came from an aerodynamic shape back to its high shape. And that's what is the mission of this trailer. It's flexible to its mission. So if we have low cargo, the roof can go down, and we also go down with the CO2 emissions. It can take every shape we want. It's driven by 4 electrical controlled units, and we have 4 pieces of the roof that can go in a different position. The trailer also has a flexible docking, double stock system. And with a double stock system, we can create up to 68 pallet places. So that's a double of a normal trailer. And if you want to put 68 pallets in a trailer, it's a hell of a job to make a planning for that. And that was a bit the problem of the trailer. How do I plan that all those pallets get in the right position and that they don't overlay the axles? And for that, we had an idea of a software program that was Puzzle, that was made already to optimally load Euro pallets. If we could change that to load this trailer. And that is what Agnes will present after Gafur. What the ideas of the Puzzle software is in combination with this trailer. What you also can see that the trailer was fairly high loaded when it was driving in the low position. So it's also very important that we can measure the volume of a trailer. And that was also an aspect missing in logistics. What is the exact volume of the trailer? What is the shape of the cargo? And for the shape of the cargo, how to see what the shape of the cargo is, the cargo volume detection system was defined and developed by ZF. And Gafur will now take you in what is the cargo volume detection.
Thank you, Ton. Since you arrived here, you already see on the big screen the ZF cargo volume detection prototype. Before we start with the live demonstration and with the unloading, you see the forklift is already ready there. And you see on the right here in the trailer, there is already some cargo inside, what you again can see on the big screen. The cargo volume detection already is running and working. Let me give you just a short introduction so that you can understand what will happen here and what you will see there. So in the trailer, there is a cargo volume detection system set up, installed in the trailer. Hopefully you can see it from there. There is a small sensor. It's a depth-aware time-of-flight sensor installed right over the doors. And these sensors are connected to an onboard telematics unit normally, which retrieve the detection results, what is visualized here on the big screen, and normally forwarded to either the display or to the backend, to the cloud, where it can be further shown and visualized and processed. These time-of-flight sensor technology measures the cargo space. And yeah, the detection results on the left viewer, there are two viewers here. The left one is showing you the raw data of the sensor, measuring the inside of the trailer. And the right viewer is showing you the calculation, let's say, of the fill grade of the loading space and the volume. And yeah, Klaus, if you may please start with the unloading. What you will see is that one of the first pallets, for example, on the left or on the right, let's see, will be unloaded. And you will see here in the real-time calculation of the fill grade of the loading space, yeah, how the volume decreases by unloading pallet by pallet. And you can see already on the left, but also on the right, you can see the arms of the trailer and in general the trailer and the movements there, that the calculation already somehow detects the height of the trailer. This is like where the movements now happen. And yeah, it will take now a little until the first cargo is removed and unloaded from the trailer. So there on the left part and the raw data are as well some intermediate calculations ongoing and showing you how it looks now. And you can already see a little, there is something inside, that's a forklift. And on the right part, yeah, we will see in a few seconds when this gets unloaded how the volume, let's say, calculated here, which is again a grid-based approach. You have here like these pillars in green, what you see for especially. These are the heights per cell. And you see on the left of that height profile that the removed cargo is not there, so the height decreased, the volume is now decreased, and you can calculate it very precisely by knowing the positions of the cargo and where there is free space and where there is occupied space. So the next cargo, that's the right cargo pallet on top of the double floor, which will be removed now. And again, you can see now again the arms of the forklift entering it. Also the height profile detects these arms as something, because it can detect and see the height of the arms. And this is shown in the right height profile viewer. And yeah, some intermediate calculations also on the left part ongoing. And now you can also see it in real time. What is remaining now, if you look inside the trailer, you can see that there are remained 2 double floors. And this is also detected on the right viewer, for example, as occupied space. And as soon as the forklift is ready with placing that cargo outside, we will see that as a last step remaining here, that the double floor is lowered down. And afterwards, we will then also see in the calculations that, also there, because the double floor will be lowered down, the volume decreases. There is nothing in that space. Yeah, again, you see the arms of the forklift, and Now this takes just a few seconds to prepare the double floor so that it can be lowered by the forklift. Yeah. So the second double floor will be not lowered down due to time constraints here, just the first floor. And yeah, let's have a look also on the double floor. Ton will show it afterwards in more detail. Give you some more details about the double floor. And again, you can see here in the volume detection, the forklift, since it is inside the loading space of the trailer, yeah, it can detect the forklift, it detects in real time there is something ongoing, the height of the forklift, yeah, in a dynamic way. And let's just wait one or a few seconds more. The double floor to be lowered down. Then the arms shouldn't be seen there anymore. So it's still partially of the forklift is shown there. That's why there are a lot of calculations ongoing, since there are different movements ongoing there as well, with the arms going up and down. You can see there in different colors, and that there is a lot of change just because of that. Yeah, so very close to be lowered down. Okay, so the double floor is lowered down. The forklift is outside of the trailer, and you see the double floor is not there anymore. So the last final fill grade of the trailer is shown. To give you an outlook in general of this prototype development, yeah, this helps to improve the loading, cargo loading space, efficiency and optimization, and indirectly also the aerodynamics efficiency by providing such height profiles in general. And yes, ZF strongly sees it as a high potential to continue the further developments. In-field tests were done, and the next in-field tests are to come in the near future. So I'm looking forward for later discussions after these demonstrations here with you. So please get back to me with further questions, and I will hand over to Agnes for the next presentation. Thank you.
We have to switch the screen. 1 second, please. Well, I'm now from the other perspective. I'm from the logistics perspective, how to plan to use this innovation. From our point of view, there's a high potential on use of the double floor, but it's not that easy to plan it, because usually you just use the floor and, for example, here Klaus has to plan where to put which pallet on it. In total, you can count that you do not load too much on it, so you have the restriction of the weight, and from the experience, the most people know how to load. But if you're on double floor, so this is then another complexity. You see, you can lift the double floor on different levels, and you have high pallets, you have very low pallets, and you have heavy pallets, and you need to meet all the legal requirements, all the legal restrictions of this trailer. So this complexity we try to solve with our puzzle software. Puzzle software is very much known in optimizing the pallet itself or boxes. So which packet you put on which part of the pallet to get the right weight on it. And it's, the name already says it, it's a puzzle. So it's algorithms behind it to optimize it like a puzzle. We focused now to do the puzzle software, and we adapted the software to the trailer problem and to the weight restrictions, to the axle load. What you see here is our demonstrator, which is online. And we just go to it. Well, And first of all, you have to choose which kind of trailer you want to load. So you can define it here with a detailed level to say what kind of trailer you want to use. And today we want to use our AEROFLEX double stock. Then we need to know which loadings, which pallets we want to load. I just prepared here some data, some air freshener, shampoo, and you can see, of course, the which part it is. So we have here the length and the width all the same, but you see the height is very different and the weight. Then you go for loading. And you have your first results. You see here on the left-hand side the 3D version of it. Here you can control if everything is loaded you plan to load. So 10 of 10 are loaded. And if you go up here, you have the different variants, different versions of the loading possibilities. So this is we do not say loaded like we planned, but we give you a lot of variants to say, okay, which one is the best one for you? So the planner can decide in which version he wants to use it. For example, here you have the version you can lower the roof as well. Still, you see we have loaded 68 pallets on it. So it's the most, you can use the room, the space of the trailer. In total, we calculated here a usage of the volume of 92% and of the weight of 82%. So we put everything on it, what is possible. This, of course, is a very good example to show what it's the optimum. But in real life, of course, we have other data. We don't have exact 86 pallets which are matching to one trailer. So in the real test case, this was the use case of Procter & Gamble. And in total, we there find there the example that we reduced it of 38%. So for our point of view, there's a lot of potential in using it, not only in the optimum data, but also in real life. Thank you. Go to.
Thank you, Agnes, for your contribution with your puzzle software. It really helps to get this new system of the flexible floor on the market, because it's a real puzzle to plan this trailer and to use it as optimal as can be. So you've seen now the functionality of the trailer, of the flex floor. The driver puts up the levers, you can lift it up with the forklift, and then the positions are marked and they can be all set for the complete trailer at all levels that you want. And then you just push it up and it stops at the end, and then it's locked automatically. And then you can put pallets under it, and to be able to pallets on top, the roof we designed can go up 10 centimeters extra above the driving level. So what we can do is this system, we make the trailer 10 centimeters higher. The driver already puts it in that position, and after loading the trailer with the flexible floors, he puts it on the driver position, and then the trailer automatically goes to its dynamic shape, or what is maximum possible to reduce the drag of this trailer. So these are all options that we did in the trailer. We made a flexible floor, let me say, mechanically, but we are still thinking of what would for you be the best option. Is this acceptable to make it that the forklift driver needs to do it, or is there a need for this completely automated, like the roof? And the roof we made completely automated because the people said, oh, else the driver never will use it. But it makes the system more expensive. So feedback from you could be, it's too expensive to make it like that, always do it by hand, because that's also possible. We can also make the roof by hand, and then it would be much cheaper, but you get the return of your investment much quicker if it would be mechanically driven. So this is the concept from came from the Transformers project, but I already was in another project, and in that project we developed the NMLU. And the NMLU is the new modular loading unit. And in that project we had a challenge to make a new unit between a pallet and a trailer. And we came in the end with the new NMLU based on this plate which you see in here. So this is an aluminium base plate, and we defined 4 types of NMLUs, all on this base plate. And in this base plate are interfaces to secure cargo, to lift it up with forklifts, and also side guide systems to automatically secure it in the trailer. And we come from the air cargo distribution. So in air cargo systems, all goes over roller beds. So with this NMLU, you can do a very fast loading and unloading of trailers and go with this NMLUs through the warehouses and very quick to do transdocking. And I said we had 4 different types of NMLUs, but all based on the same base plate. So we had a type that it was let me say, a part of an ISO container, a steel building on it. The second type was this one with a box like that one. And then you also could do a double stock in there. Another type that we used, the stackable pallets. That's what you see here. So this is a pallet which has a hood over it so that you have here interfaces to put other pallets on. And with different type of hoods, you can fill the trailer up to 3 meters height on that aluminium floor. And with that aluminium floor, that will be automatically loaded, so you can fill up the trailer up to the roof. The last version we had, that's what we called the Modulusca NMLU, and that was built of different crates. So we had a system that you have pallets in shape like this with different crates, big ones for, let me say, the lightweight diapers, or little crates for the heavy washing powder. And if you mix it, you always come to an optimal filling of pellets, and then we optimally can fill the NMLUs up to the roof, and products can stay in these crates through the complete logistic cycle. And in the end, we could stop with using cartons, because these crates will even end in your house when you are getting deliveries from groceries or your shops. So this is a bit the idea what we started in to get the, let me say, modularity into the logistic systems with the NMLUs. Yeah, that was a bit the end of our story. I don't know if there is any time for questions. We had some kind of maybe wrap up that Gafur can tell you about what his next things to do will be with the cargo volume detector. And Agnes about what's the next steps for the puzzle software.
Okay, thanks first. Okay, so let's open the discussion round. I gave a short...
If there are questions, you can ask them us now. We have some time. If not, then we tell you about what's next for our development of the cargo volume detection.
Yeah, I gave already a short outlook of the next testings upcoming and the developments. There are short-term, mid and long-term views on that, of how we will continue with such a cargo volume detection solution beyond the prototype that was developed here during the AEROFLEX project. Yeah, one is, for example, feeding these kind of activities in the next innovations within ZF, and in the mid and long term. We have go-to-market between 2022 and 25, and we will extend, let's say, the features and yeah, go to commercialization in future. So that is very roughly an outlook of what is coming next.
Well, for the puzzle software, we want to stay very much in contact to John and the double floor trailer. So we have there some plans. But additionally, we are in contact to industry partners which are interested in just using it for optimizing the trailer itself without a double floor, because it's a problem. It's not very much solved at the moment to meet the legal requirements of the axle load. So this is something for the future we develop in 2 directions.
Thank you. There are some questions, I've understood. I see the microphone, Steve.
Hi, sorry, I don't want to dominate all the questions, but you just mentioned the axle load, and I'm wondering, often one of the issues is not the initial loading condition, it's when it's been unloaded partially during the journey. And does your software take that into account? And I guess, is the idea that the software would be loaded as part of the load detection system? Can it be updated, throughout the journey?
At the moment, it's just a planning tool. So if the planner wants to update it, he has to run it again. What you can easily do is just to delete some of the pallets, and then you see if the rate restriction is still okay.
But in terms of the order in which you load as well?
Yeah, I think we can optimize the program that when it's loaded, then you do a sequence when getting pallets out of the bag, what the weight distribution will be. It's not in the software now, but it's a next step, and thank you for your advice. we can take that in the next things to do.
Right, more questions? It seems that everything is very clear. Okay, then yes, I would like to thank Ton. Have you still something to add, or?
Yeah, we also want to continue with the double floor system, and we are now talking with a company like Procter & Gamble to go there for 3-4 months just to test the double floor system and the roof. But if other companies would be interested in getting in a test cycle with the trailer, they can always contact us, and we'll see that.
Okay. So if you are interested, since we are not moving now on this deck, those who are interested, we can join the people on the deck. You can have an inside look in the trailer, and after that we go back to the hall. So take the opportunity to have a closer look, and after that we go back in the coach, and then we go back to the hall to prepare ourselves for the lunch. Thank you very much, and please join us on the floor.